All right. Change this to the low profile mic holder. Um, Today seems like it's going to be a huge pain. So I am going to time box it unless we're making some serious progress. Day 23. Why is this copy taking so long? Code dot. We have got a BS code open. I clean this up as people filter in. Get rid of all these tests and things. Turn off all these bulbs. I think we're going to use a B tree map today. Let's get rid of all these structs. Not the puzzle input thing. I actually don't know if we're going to write a parser today. Today seems like it almost doesn't make sense. So let's check out what's going on for day 23. You can see we're starting to not hit the part twos, which is what it is. So today's problem is, how do I explain this? Basically, we have this structure here. And if I make this gigantic, you'll probably be able to see it. So we have this structure here, and the idea is that we have these like slots here. And the thing that we need to do is like take this and move it out over to here and like reorganize all the slots until we get this output. So A, B, C, D in all the appropriate slots. And each of the moves costs something and stuff like that. So yeah. So this is like I think it's another one where, well, okay, so let's go with this. There are a couple of rules for how things move. They can't stop on the space immediately outside any room. Let me hold this up so we can like show a little bit of an example. So they can't stop on a space outside of any room, which means like this dot, this dot, this dot, and this dot. No goes. We can't move there. So you can't like block a room with a letter. We'll never move. Let me do this for a second. I remember doing this last year. There we go. Now we can actually have it on two. So amphipods can move up, down, left, or right, so long as they're moving into an unoccupied open space. The first like condition is that they can't stop here. The second condition is that they will never move from the hallway into a room unless that room is their destination. So if we have like, this doesn't actually show anything moving, does it? There we go. If we have like a B hanging out here, it can't move into C's slot because that's not where it's supposed to end up. But if we have B here and there's a B slot open here, it still can't because there's a D in the B slot. But if D moves out, then B can move in. But it can't move out of the hallway until then. And then once an amphipod stops moving in the hallway, it will stay in that spot until it can move into a room. So the other thing is that when it comes out of like the slots down here and it goes somewhere, it has to stay there until it can move into its own slot. And then eventually we end up everything moved into different places. And the goal is to each of these, when they move, have a cost to move. And I think it's like, what is this? Is that D moving? Oh, please tell me they didn't name like the copper amphipod letter B. Okay. No. Okay. We're good. So this bronze frog or whatever moves in the hallway. It goes 1, 2, 3, 4. So I expect this to take 4 times 10 because where's the definition? Yeah, so 110, 100, or 1,000 is ABCD cost, but it's 1 per slot. So it moves out and over 3, and that's how we get 40 for the cost of this move. So basically we have a bunch of potential places that we can, or like states that we can be in. And all of those states have a cost to get into. And if you remember that we did some graph algorithm stuff in the past days. So I think that to solve this problem, we basically do the same thing. If we can generate all of the node paths, then we can use that as one really massive graph. At which point we can like use a shortest path algorithm to figure out which one is the shortest path to the end state. So that's what we're up to. I don't know what data structure we're going to use for that. So parsing it is a little weird. I guess we only have one hallway, right? Let me copy in the it doesn't even give us a test, right? So is this all of the there we go. 12,521 is the answer. So we have a test down here, and our test needs to be 12,521 for the input. I actually don't know if I'm gonna do the input here. I deleted the include bytes, didn't I? Let's do const input equals like nothing, basically, for the moment. Because I don't know exactly what data structures we're going to use yet. And I don't want to... Oh, it's end static string. Yeah. End static string. Wow, I'm not... Okay, end static string. Because I don't know what we're actually going to do here, so I don't know what to parse into. So we're going to take a minute before we do the parsing stuff. We're going to decide what data structure to use. We're going to solve the problem, and then we'll go back and we'll actually write a parser to parse into that data structure, which we can then operate on. I feel like for most days it's a pretty easy, like, oh, it parses into like a list of tuples or something. But today I'm not sure. I guess we could use indexes. Like we could have, what, like a map, and then we could have a hallway, which is like a vec, right? And this is like a vec of some car. And then the hallway would be the full length. And then we would have slots, which would be how would we parse slots in? Slots would also have indexes, right? But we kind of have to, so we have to count them. Let's make this a vec of cars, I guess. That doesn't feel right. This I'm just going to say like a vec of use size or something, and this is going to be like entirely to dude. Yeah, you can just say what it is, what you think it is, Commander. You don't have to like try to lead me around in a circle to get to the thing. Like, I understand that I could represent that entire grid as like a 2D array. So we can just have a conversation about what you think the answer should be, rather than like you trying to guide me through YouTube chat to a thing. What's the problem here? Cargo. Oh, car is going to be like a parser, right? Because I accidentally have it imported here somewhere. I don't. Why is that? Why does that have a problem? Oh, some option car. I'm out since day 19. Okay, so we have the hallway and the slots. The only thing that we need to encode here other than the hallway and the slots is the cost. So the cost to get to this point kind of thing. Because this map is going to be our graph node. And then the cost to get to the next graph node is going to be whatever cost it was. Actually, it's a different cost for every node, isn't it? Yeah, I think we need to include cost here because we need a situation in which we have the same map state that costs a different amount to get to. Right, so I think we need to encode the cost there. Unless we want to write the algorithm for calculating the cost, which I don't know if I can do in this situation. What if it is a node, then we need no vec inside? No, it's not a node of the individual. Okay, so let me explain this then. It's not a node that is like this slot and then this spot and then this spot and then this spot. Those aren't nodes. This is a node, right? We've got the node that represents an empty hallway BACD BCDA. And then we've got another node that represents B in the hallway with BACD empty CDA, right? So it's complete map state to complete map state. Because the search that we're going to do is going to be from whatever state that we're in down to a completed state. So we're going to have things like, let me pseudocode this. I guess we can't keep the cost in there if we're going to search for this way, right? So we have to do the cost some other way. So we have to be able to determine the cost based on just the movement. How do we do that? In any case, the let's say we don't include cost here, right? And we've got map. We've got, let's start map equals map. We've got an empty hallway, so we've got a hallway, which is a vec. Of none for how many inputs? 0 or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is like a vec hallway none 11, so there's nothing in the hallway. And then what was the other thing I called this? Slots. This would have to be a vec of vecs if I was going to do it this way. So it would have to be like this, right? And then it would be, what's our starting state again? Starting configuration. So then this has to be like vec B, I guess AB, right? We'll do 0 as bottom. 2, 3, 4. So D, C, this is B, that's C, this is A, and this is D. So this is our like start map node, right? And then the goal is that we have like this, and then this is like AA, BB, CC, DD. And the goal is to construct all of the possibilities for all of the places that all of these nodes can be between this start map and the end map. So we need to have some cost function, right? So function cost. I guess we'll know what the cost is based on the move, right? So we know when we generate. The problem is that if we generate it that way, then we just get a list of all the map. If we're already generating all of the nodes in the map, then we get the cost anyway, so we don't need to do a search, right? We just do it until we generate all of the possibilities, and then we have all the maps at the end, and all of the end maps will have the cost that they take. Which could work. Is there any other way we can do that, though? Because I feel like that's going to be maybe a lot. We're just focusing on part 1 right now, so it doesn't really matter. I think that's what we have to do. I don't think this representation of the map makes it very easy to work with, either. Because, like, the VEC doesn't encode, like, the number of spaces or anything, so we're just kind of holding that. Hey, Nikki, how's it going? I think really what I want here is something more like this, where the start map is... Well, if we do that, then how do we calculate? So if I do a B-tree map of all the different rooms, how do I calculate how much it costs to get to that room? Because we have to encode, like, how many steps it takes then. Doing part 1 today manually, still working on part 2. Then do it like it is in the real display, map the walls too. I don't see how mapping the walls helps us. I mean, the walls helps us if we map the walls in the slots. So maybe this is... Maybe this is not none, but some kind of enum. Enum space empty filled blocked. Empty filled. I guess filled is blocked, right? So if this is just some. So it's either none or some. So the problem with that, Commander, is that if we do one step at a time, then we have to encode that it can't go back and forth, right? Like, if we do, like, do you get that? Like, if we do left and right and up and down, then D can move to here, and then the next step D can move to here, and then the next step D can move to here. So we would have to, like, keep track of where it's been and then block it, and that doesn't seem like useful stuff. Occupied is better. Yeah, we can use occupied. If I can spell occupied. Is that how you spell occupied? Yeah. So realistically, We can pop off a vec, right? Yeah, we can pop and we can push, which is good. So these representations are okay because we'll pop this off and we'll put it somewhere. And then, like, if the vec is 0, then we can push back on, kind of thing. I'm trying to think of how to encode the cost, though. Because if we have... I guess we can count the number, right? And then add 1 if it's in the bottom of a space. So if slots is encoded as being the same length here, which means this is a different thing. So we either have spaces or we have slots. Homes. I'm going to call them homes. So we just skip over all the walls and we do home as a vec of cars. And then we do for 11, this is wall. And these are all home. It's a little bit awkward. Why is that complaining? Expected vec found homes because I made map the other thing. Where's map? Map is a vec of homes. Hallway is space. Right. And then home is a vec of spaces that are occupied. And this is empty. This isn't particularly... This is going to be a little bit wordy, I think. Right. And this is... Those are supposed to be empty, right? Let me just get that out of there for a second. Trait clone is not implemented for space. That's fine. We can do that. Derive. Let's do a derive on these for debug, clone. Do we need equality? Yeah. And then basically I'm going to do the same thing for homes. Now the goal map is empty, 11, and these. Why didn't that work? That was annoying. So home has a bunch of occupied, and then this is what? Wall, wall, slot, wall, slot, wall, slot, wall, slot, wall, wall. Right, so we do this, 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 and then 2 on the end. And these should match up. 1, 2, 3, 4, 5, 6, 7. And then we have the index here that it will be at and the index that it ends up in the hallway so we can get the distance. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is how we're going to parse this out, I think. These are the nodes that we're going to have. I don't know that we need the nodes per se, because if we're doing all of the... If we're iterating over all of the rooms, then we don't need to do a shortest path because we can just do an iteration over all of the end maps. I can't think of another way to do it because otherwise we have multiple moving characters. So we aren't going to need pet graph because we just need to iterate over everything. Anyway, we need to build out all of the turns. There's got to be a better way to do that. But I don't know it, so that's just what we're going to do here. Okay, so it's got start map and goal map, and then we need to like start map dot enumerate moves, right? And this will return us like a vec of maps or something, like all of the next possible maps. The cost here is going to stay in because we're about to generate everything. So this is going to be total cost. It starts at 0. We still have to do total cost. This is not valid for the end map. So maybe we don't keep it in the map. Maybe we put it, like, keep it in a tuple as a separate thing. That seems to make the most sense. So, like, start map that enumerate moves current cost. And then we can impl on map, enumerate moves. That takes a current cost and returns like a vec of maps. Why is that unhappy with me? Oh, right. Self. This is an associated function, not a method. Expected vac found unit. Okay, that's fine. And then we just do an empty array here. And then now we need to take the thing we have and calculate the next possible move. So I think the first thing we do is move from hallway into slot if we can, right? So we go through everything in the hallway. If it can move into a valid slot that it's supposed to be in, then we try to move it in there, right? I think that's the first thing we need to do. The second thing we need to do is if we can't move from the hallway into a slot, then we move from slot into hallway. How does the animals are allowed to move for every species? These are, I don't think these are these, I guess these are animals, they're amphipods. They're allowed to move from their slot to a position in the hallway, and then they have to stay there until they can move into their slot. So theoretically, if we just keep enumerating moving the characters out for each position, so like for example, we can't move anything in here, so then we just go to the first slot and we say, okay, B moves out. Maybe B moves there. B moves either there, or there. So 1, 2, 3, 4, 5, 6, 7. There are 7 possibilities for B to move out into, right? And we make sure that the thing that's moving out. So I'm just going to pseudocode here, fn, then move out. If we move out, we have to take next invalid car. Take next car that isn't in the right spot and can move out. And we move it out. We aren't doing one step by one step, so we don't have to worry about that, Commander. And then fn move in. We're going to call this move to end slot. That's going to move to hallway slot. Current cost is use size, so the first thing we want to do is try to move from the hallway into a slot. If we have something in the hallway that has a valid slot open, then we do that first. So move to hallway slot. We have to get the map, right? That is going to return a map. So we get map dot hallway dot iter dot numerate dot filter what is it? The I and then the item. And that's map.hallway. Hallway is a vec of spaces. Spaces, so we match C. Why is it telling me that I can't do that? Anyway, so space is either going to be, what is it, empty or occupied? There's a crate on Rust, or there's a crate on crates.io that writes out these for all your items for you. So instead of doing this kind of like match thing that we're doing here, you would get like a c.is space, which is a very cool kind of like additional piece of functionality to get. This takes not a map. This is a end map, right? Just gonna capitalize that. This is never used, so that's that. So this is movable cars, right? For the moment, it's movable cars. So this is everything in the hallway that could move. And then we need to get all of the possible slots. Slots.iter .numerate .filter. And this is going to be I and I'm just going to call it slot. Let's do, I guess it could be wall, right? So match home. If it's a wall, then it's false. If it's a home, then it's true. So now we have a syntax error. What is our syntax error here? Mismatch closing delimiter. Okay. Match is closed. Home is closed. The tuple is not closed. I think this might be filter map. So we get all occupieds, we get all places they could be. We now need to see if we can move one into a possible slot if it fits. we need the full list of characters, right? A unique list of characters here. So let me just do this for a second. And if this gets bigger in the part 2, then whatever. Let car set equals B, C, D, and we can parse this out if we want to later. I'm just kind of hard coding it for now. So we have an array of this, and then we also have the slot that they would be in. So the slots and the car set should line up. So we can only do one at a time, right? Move to hallway slot is not move everything to hallway slot. It's just move one to hallway slot. And we need to do that for every single one of them. So maybe this is the wrong function. Let's comment that out for a second. Think about this. When we go to enumerate the moves, we have a map, right? If the first thing we want to do is move from the hallway into a slot, we have to go through all of the characters that can move, which is potentially these, right? We can only take the ones that can actually move to their slot. So for each possible slot, which will be one of these, right? For slot in possible slots. Because from the hallway, you can only go into your slot, right? So for slot and possible slots, let's do possible slots .zip car set. I think that'll work. Yeah, that'll work. So for slot and slot car, right? Because we'll have the homes on the left, the index they're supposed to be in, the slot car that they're supposed to have on the right. I'm going to call this slot index. Because we're basically going to be like, can you move to this spot in the hallway? So for slot index, slot car, and possible slots, we've got each of the slots, and we have potential characters that can move into them. We're going to build up a set of possible new maps, right? And I think that vec is just like untyped, so that's why it's a problem there. And let's say this is going to be interesting because for this given map, if we can't move from a hallway into a slot, then none of these will pass, right? But if we don't move from a hallway into a slot, we still want to try to move out. So this isn't going to be the total set of maps that are possible, right? This is going to be just a set of maps, and then we're going to run the next one too. And that'll give us all the maps. Let mute new maps equals vec. We're iterating over the possible slots and the character that are supposed to be in them, which means that if we iterate over... My keyboard wants to work. Movable cars dot foresee in movable cars, right? Why is that? I'm just going to make sure that it's infer type. Yeah. Foresee in movable cars. Is this C supposed to be in this slot? And is this slot so this is going to be a reference issue, right? So method not found in homes. Dang. I know this is a home. So because we're not going to have any. So this would normally skip over, I think, any of the ones that weren't homes, but we don't have any non-homes in here because we just filtered them out. So for slot index home slot car, and this is expected tuple found car. Why are we expecting a tuple here? Because this is a tuple. And this needs to be occupied. So if we compare these, no implementation for ncar equals car, right? Cool. So now we're at a place where we have a home potential. We have a character that is supposed to move into that slot. We have a slot that is potentially, but not guaranteed to be open. And slot.iter.all. We'll do C here again. And C equals slot car. So all for an empty iter probably returns true, hopefully. If it doesn't, then we have a problem. Okay, so now we have a possible slot, right? The possible slot has a character that matches the character that we're trying to move. The possible slot has a length less than 2, which means that we have a potential open slot. The slot itself, if it contains anything, everything in that slot is already a character of the same type. So if we have an A in slot 0, right, for slot A, then we can move an A into 2 in that slot. Then we can move the character in. If no cars in hallway are blocking, then we move the character in. So let's clean this up a little bit with a couple comments. Have 0 or 1 car in it to be able to accept a new car. Slot members must all be the valid slot car to be able to move a hallway valid slot car in. Right? If the hallway car is a valid car for this slot. So now we just have a ton of comments here because I'm going to forget. So that's why I wrote them. And then we do also need to check if no cars in the hallway are blocking. Can we do this in the same place? I should have named this hallway cars. And movable cars. What do we do here? We don't want these to be the same iterator, actually. So I think we need to collect up here. This is movable cars equals map hallway iter filter dot collect vec usize space, right? This is not collecting into the right type. So what do we have here? Rust compiler. Use of unstable feature allocator API. Oh, let's not do that then. Space isn't a reserved word, is it? Space doesn't exist in here. Why does it think I'm trying to use the allocator API? There's a dedicated working group for this. That's interesting. Oh, because it's a tuple and not... So a value of type vec usize space cannot be built from an iterator over elements of type tuple usize reference to space, right? So that's totally expected. And apparently there is a syntax that is not this, but is vec usize uspace or reference to space. And I'm really curious as to what that is. So allocator API, heap. It's not immediately obvious to me how this is relevant to the collect syntax, but my guess is that when we create like an array or something, that we can, or like a vec or whatever, we can specify the size that we want. I bet you if I actually read the RFC, I would know. But that's my guess. Basically, this is adding something that eventually gets into the high level collect API so that you could potentially change the way that your collect allocates in the future, is my understanding of what's going on here. I actually haven't read this, so maybe I'll go back and I'll save that for later and I'll read it. But that's my understanding there. So expected bool found struct back. We are still down here, and we are movable cars.iter. I think what this has to be a dot iter. No, it doesn't apparently. Okay, I bet you it'll tell me that it has to be after this. Movable cars.iter. Dot find. Do we want to find? So if we find a car that has an index that is greater than, well, that is between the range of the space index and, so can we get the range here? Slot index. And I don't think we can go backwards, so we have to make sure that we construct this range in the right direction. Just to check that, we can go to Rust Playground. I know that for negatives it didn't work. Let's do fn main for I in like 10.1. We'll just debug I. We'll run this and see if it works. And it doesn't run anything, right? So if we go from high to low, it doesn't work. If we go from 1 to 10, this will work, just to confirm our assumptions here. So we can't go from low to high in a range, which means we need to make sure that we construct the range correctly. It doesn't really matter to us either way, because .find, I don't remember what this type is. Rust Analyzer tells me it is a index and a space. So what we want here is a index, and we're not going to use the other thing. And in here, what we're going to do is slot index dot what's the car index? I, right? Except what we're going to do instead is slot index dot max I and slot index dot min I. So now we have a range that is guaranteed to be low to high for these two numbers. Contains index. And this is in a Boolean, so it's telling me that I can't do that, right? There are two options here, I think. Rust, iterator. Let's go check to see if there is a find. I guess so there's two options that I can think of. There's find map, and there's find and then. So we could find map, right? And map this into a Boolean. Our other option is an unstable nightly. I think actually it might be stabilized now. Rust, bool, then some. Maybe it's the other way. Rust option. Boolean operators, and then or else. These are not what I want. Is some. There we go. We'll use is some here. And we want it to be is none. Is contains not the right thing there? I thought contains worked. Dot max is going to return like an option type or something, right? Closure is expected to take one argument, but it takes two. Why does it take two? Because I didn't write a tuple here. And then slot index min. I think I got the type signatures mixed up there. Expected bool found range. Oh, because this whole thing. And I think now we have actually suitably identified the difference there. Let's make this a vec of usize for a second, just because so we can get the other errors. This is a reference. This is a reference. Actually, that's not a reference. I don't think we need to access this again, so we'll leave it there. What is I here? Why are we complaining? Found a reference to a usize. Can we not destructure in this tuple? Doesn't seem like it. We can dereference the usize here. Is occupied going to give me a problem here? That's unfortunate. Pattern not covered. That's okay though. Dang, I thought it was going to let me do that. The Rust compiler making sure I'm complete once again. Occupied C. I mean, is there a way to do this where I guess we don't need to unwrap this, right? Because this is all in the same. So if let occupied C then we do this. Else false. Floss? Floss. Don't forget to floss. If let occupied C equals C. That seems like it works, right? Did my formatting break? No, we still have another error. Okay, I think that works for that. And then we need to do the same thing up here. And then we do the same thing up here. Dang, that's really unfortunate. I didn't want to have to do this. So this is... Maybe we just map this to a car because we already know it's occupied, and then we don't need to deal with the fact of whether it's occupied or not. Where are we doing movable cars? Movable cars is up here. We already filter out occupied here, right? So let's do filter map. I think this has to be none now, and this has to be some C. And this has to be IC because it is an individual contributor to this program. Okay, so that's fine. And then this is just C now, which I think we own, right? Just cleaning up the types here. No implementation for space equals car. I see a space. Because this needs to happen. Cars implement copy because they're a primitive type, so I'll just dereference there. This is slot.iter. So slot.iter will have to do the occupied thing that we did before. This is an iterator over possible slots and car set. Possible slots we already pulled out. So maybe we want to do find map here too. And then this also has to be the same I thing that we did before. Filter map. And then this is not home, this is just slot. Okay. And that all works. It's quite a bit of code actually, and I think I've broken the formatting. Okay, so I broke the formatting. Sorry, this won't be auto fixing itself. Eek. What do I do now? Do I just close it out and bring it back up? Maybe that'll work. Watch VS Code be like, time to update. It's just totally not auto formatting anymore. Dang, that really sucks. Oh, there's the formatter. I think it just takes a minute for Rust Analyzer to kick in. It's definitely not auto formatting though. That's unfortunate. This is going to be really awkward. Dang it. Dag nabbit. You know what? I might be able to cheat, actually. Okay. So that worked. This is getting quite wide though. I think I think the problem here is that I moved so far deep into this, like horizontally, in nested structure wise, that Rust Analyzer is just kind of like, yo, you shouldn't be doing this, which is right. I shouldn't be. This should probably be wrapped up into a nice little like is whatever or something. It's not. So let's put a comment here. Movable cars.iter. Okay, and now we move the hallway car in. It's not nested that deep, is it? Asking for me, I've definitely done that. I think it is, Nikki. So we're in an impl map, which defines a function move to hallway slot, right? Which is in a for loop, which is in a for loop, which is in an if statement, which is in a closure, which is doing more stuff. We're like seven nests deep or something like that. 1, 2, 3, 4, 5, 6. We're like 6 or 7, depending on what you're looking at. Which is a lot. Like it's a lot for programming. Like going 7 tabs deep. Like you can see it starting to move halfway across my screen here. Like 1, 2, 3, 4, 5, 6, 7. And then this one is technically 8. So, I mean, it's deep. It really, realistically, this is not the way that I would write a maintainable piece of code. But that's not what I'm trying to do right now. Okay, then move the car in. Otherwise, we do nothing, right? So if we move the car in, then actually, you know what's going to be fun about this is that we're going to be able to actually test this. So let me write a test quickly. Let's do like an easy end goal map. And let's do test fn test move in to slot assert eq this, which is the goal state. And this is not going to be the goal map. This is going to be empty, right? And then let's just do, there's 11 here. So vec like empty, and then occupied, and then 9 more of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So we've got an occupied A in like slot ID 1. So it's actually slot 2. It's somewhere in the hallway. And then we've got the slot here. And this is going to be complaining because I made syntax errors, and this also needs to be move into, I forget what I called it. What did I call it? Move to hallway slot. This is going to be a self. Why is that bad? Error reporting overflow should not reach report selection error call. That's fun. Map and self. Is it capital S? Expected type found module self. Oh, you know what the problem is? There we go. That's what I need to be doing. There we go. That will work. Map.move into hallway slot, which should return a map and does not. And our tests are not compiling. Cannot be formatted using debug. We need to put debug formatter on the map because we didn't do that before. This is no longer a graph node. Hash derive debug equality, partial equality. Anything the compiler wants, we give it at this point. Okay. Move to hallway slot panics at not yet implemented because it panics right here. So if we run the test again, we should say panics at not yet implemented here. Right there. So let me comment out the first test because that's just not going to work for a second. And now we have a test, so we can actually start testing this. Move to hallway slot. We need to move the car in, right? This is actually going to be a vec of these, which is going to be funny. Yeah, then we move the car in, right? Is there any other... There's no other thing that we need to do. We just need to create a bunch of maps that have the new car in the new spot. So if we take self, and we clone it, then we have a new map. Let's say this is mutable. Let's say we have a character at a point in the hallway that we need to move in. We know where we need to move it already, right? Because we have the slot and we have the... Yeah, we have the slot index. We have the car. So new map dot hallway dot what? Index I? No, it's not going to be I. It's going to be like slot index. So new map dot slot index is going to be where we put the character, and new map dot hallway I think I is the right one. Yeah, we should name this car index. Really, did we use I anywhere else? Let's do this car index. I guess this is empty, right? This is empty. Slice indices of view size or ranges of view size. Space cannot be indexed by a reference to a view size. That's fine. So it basically was like, hey, you can't use a reference here. Space cannot be dereferenced. I don't want to dereference space. Can we do... Let's do this to be more explicit, actually. Hallway.get mute. Right? Let old space equals this. Why is that complaining? New map is a shared reference, so the data it refers to cannot be borrowed as mutable. Why is it a shared reference? Because I'm accessing fields inside of it? Let's comment that out for a second so that we only get relevant errors. Option mute space. What did I do here wrong? Okay, so I have my new map. My new map is cloned. We own it right here. I declared that as mutable already. The dot hallway, I think we need to borrow is mutable. I think that's the issue. I think we're reaching into the mutable struct, therefore, but for some reason it thinks map. Why is it a reference to a map if I clone it? Is it just trying really hard to be a reference to a map? Method clone not found for struct map. Did I not implement clone? Is that the problem here? I didn't implement clone. Yeah, okay, so it's telling me exactly what the problem was. I just wasn't reading. That's my problem. Remember to read the errors. It's a habit that I've actually not, it's taken me a little bit of time to deal with. The habit that I've built up in other ecosystems like JavaScript and stuff like that is to basically skip over a bunch of the output, because a bunch of the output usually isn't actually that useful. You can think of things like the security audits and npm installs, and like the very verbose output that npm just like dumps into your console whenever you npm install, or like a webpack error or something like that. There's a way in which the JavaScript ecosystem produces a lot of error information that is not actually actionable. And over the years, I learned to ignore most of it, which is a skill that newer programmers have to start picking up. And they do that, and they pick it up, and they learn how to do that in the JavaScript ecosystem or something. And then they come to Rust, and they stop reading the errors because they don't think errors contain useful, actionable information. So that's still a habit that I myself am trying to pull myself out of, because the Rust errors actually do tell you what's wrong in your program the vast majority of the time. It's a way higher percentage than it is in other ecosystems. So this error in particular was telling me exactly what I needed. But instead of reading, I was just banging my way through it because that's what I was used to. So remember to read your errors. Let's see if I can get it to repop up. Yeah, like right here, error E0596, which is an error code I can go look up if I want to. Cannot borrow new map.hallway as mutable, as new map is not declared as mutable. It's telling me exactly what the problem is. New map isn't declared as mutable, right? So I need to go find out why it's not declared as mutable. In which case, that's that. But like, it'll point you to exactly the location. It'll tell you exactly what the problem is. It'll say, hey, maybe right here, you should include mute in front of new map, right? Like, all of this information is actionable, right? All of this stuff is also actionable, but it's less important, at least for the process of developing my program right now. I can silence these too, but yeah, I don't know. Read the errors because they're actually useful in Rust, as opposed to other places. So old space equals empty, right? We're setting that to empty. And then same thing for the new map slot. The new map slot, I forget what I need to do here. I need to push into it, I think. Right, we think this is a Holmes. Sherlock Holmes. Did you know that house is a play on Sherlock? Let slot equals this, right? Only now? What the Then I've clearly not sent you enough TikToks, Prince, because that's where I got that from. House, like House MD, the show about the doctor that solves medical problems. What's his partner's name? His partner name in the show is like Wilson instead of Watson. Yeah. Wilson is the other one. So it's Sherlock Holmes, like House, and Watson, who's Wilson. Oh, the one where he always solves the mystery at the end. Isn't that most shows? Anything with a mystery? I don't know. I get all my information from Scooby-Doo episodes. Slot index. What's the problem with slot index? Can I do that? Is that legal? No field 0 on Holmes? Where's Holmes? right? No field 0 on homes because it's not guaranteed to be the other thing. If let's home slot equals slot else panic tried to move into non-existing slot, then slot dot push C, right? Which is going to have to be what, a dereference here? Expected space found character occupied. This is now occupado. Okay, and then new maps dot push new map. And this is new maps. What did I do wrong? I mislabeled this. This is going to be a vec of maps. Why did I call this as a function? I don't know. This is also going to be a type error because we didn't specify that we're returning a vec of maps. In our test down here, it also wasn't expecting map or a vec of maps. So this is going to have to be a vec. That whole read the error messages thing is totally going on TikTok though. Left, right, we get nothing from right. Why don't we get anything from right? I wrote the problem wrong. It's not good. I'm glad we wrote a test. I did also just write all of this logic without even testing it. Like I didn't even run this once. Like not even, I didn't even run the test. I was just like, oh, it'll all work. It'll be fine. Definitely should go to the TikToks for this and that. Where's new maps? New maps is here. I don't even know what to debug here. Map. Self. C. And let's just do self and C for the moment, because I don't even know that these are going to show up. Do I have two tests called move into slot somehow? How is this? Why is this running twice? Right, why is that running two tests? Test move into slot. Make this small, make that small. We only have one test move into slot. I'm gonna call this move into slot 2. What did I do? There isn't some secret like assert equal on a vec tests it multiple times, is there? Okay, well, in any case, we're not returning anything because we're not getting into that loop. Let's figure out why we're not getting into that loop. I think I want to get this first part done in the next 20 minutes. Move to hallway slot vec map. Let's do possible slots, iter enumerate, filter map. This needs to be a collect, I think. usize vec space. Now everything's wrong because I'm calling it as a function because I left some extra parentheses in there. And this is now iter zip, right? And this is a vec of these. I always forget the vec, the wrapping vec around like the type for collect. Did I change what slot index is now by doing that? Why did car index change? Movable cars. I feel like that shouldn't have changed. Oh, slot index changed, therefore the function argument that we're passing in there changed. That makes sense. Okay, so that's an iterator now, and we can debug everything. Self, movable cars, possible slots. And all of these are references because otherwise it needs to clone them all. Okay, so we have a map, which is self and has an occupied in the second slot of the hallway. We have a bunch of these things, specifically a home with an occupied and an empty slot. I think that this empty slot is the problem. Let's find out. Cars, 1, index 1, car, A. So that's in the hallway. Hallway index 1, we have a character A. Possible slots it could go into. Indexes 2, 4, 6, and 8, A, B, C, and D, right? All of that works. So we get into here. And we get into here, and hopefully we make it here. We make it into here 4 times, 1 for each slot. Perfect. We have 1 car to iterate over. We have 4 slots to check. We never make it here because we are not doing one of these tests correctly. What are the chances that if I do this around the entire expression, that it will work? Yes, Rust knows what I meant. Unfortunately, there is a lot of code here, and it only gives us the output value, so it's always false. Even when I think it should be not false. Okay, so let's do this. Let's take everything that we're going to use here. Debug slot car. Slot. C. We'll put C at the beginning because we're using it immediately. Movable cars is something that we already checked and we know that it is just the A. So if these three are correct, then the last test must be the wrong one. Let's find out. Why is this test running twice? Nobody knows, but we're going to ignore it for a moment. C is A, slot car is A, so those are good. Occupied A and an empty slot. I think that that's the problem. I think the empty slot is the problem. Because what I'm doing here is I'm checking to make sure that the length is less than 2 here. So I think what I need to do is iter, filter, why do I have empty there? Why is that not just like, no, I think that's the problem actually. I think down here, instead of having empty, I'm just going to make this a single. And if I make it a single, I think that sets up correctly. Right? So now A slot is less than 2. So slot dot length. And then this thing, and then this thing. Is a hell of a debug expression. I feel like it should not do the white space, but that's fine. Let's just make this gigantic so we can read it. Okay, so somewhere in here, slot car is A. So slot car is A, C is A, slot has an A in it. Slot.length is 1, which is less than 2. Slot.iter all is true, so we go through. This is false. This is the problem right here. Hey Derek, how's it going? Also, hello Prince. I didn't say hi when you came in, but I did read your message. So let's do all of these and get rid of them. And let's start taking these little pieces out and logging them out. Can you debug in a debug? Am I really about to do that? Okay, for character A, this is the range from 1 to 2. And I think that we need to do an inclusive range there. I think that's the problem. The index is 0 though, so it doesn't need to be an inclusive range in this moment, I guess, right? So the range is 1.2, which has to include the index. Oh, you know what I didn't do? I didn't filter out the character that we're looking for, which means that it will be in that index every single time. So what do we need to do here? We need to iter filter C is not equal. Did I call it C? Am I gonna regret calling all of these C? I did. C2. We're going to dereference that to our character. And it's going to fail again. No. So our test passes. So it works. So this is, how do I, let me grab this, throw it back into here, use this Rust format, grab this, throw it back into here, save it, and then hopefully that gives us a little bit more readable output. Not really. I made a horrible mistake, basically, and I just went full on. I wonder if this test should not just be sitting in this if statement. Why did I do that? I don't care. I'm not going to fix it. So this, we take all of the cars that could be mutable, we iterate over them, we remove the one that we already have, because if we don't do that, we'll find it. But we want to find anything that could be in the way, which is one of these. So if any of these are in the way, which is if the range for the indexes contains the index for any of the other movable characters, then that doesn't work for us. So let me get rid of all of these debugs. Our move from hallway into slot is working. We test it, our tests work. That does not mean we are done. This is only move from hallway into a slot. We still need to move from slot into hallway. And then we need to iterate over all of them. So let's do one more test here. I want to make sure that this, if we mess it up, so like if this is occupied A, let's use a situation that we would actually run into. So maybe we do B here. No, let's do A. Let's do A. Let's say this is B. And we'll make this one empty. So this is a valid map state, right? In this case, we would need to move B before we moved A in. So when we do this test here, the test is going to return us nothing. I want to say it's nothing. What should this return us? We have a movable character. We don't construct any new maps because we can't move it in. So if we return nothing, then we have no moves for this, which is fine. And that answer, I'm going to type this. Answer is a vec of maps equals vec. So if we receive no maps, we could not move anything. Test move into slot 2 redefined here. Why do 3 tests pass? Yo, I'm really confused. What is going on here? Why are there 2 move into slots? There's only 2 functions to find. What did I do? Somehow the way I defined this function... Oh, you know what I did? I have an extra... I didn't comment out the other test annotation. That's interesting. So if you have 2 test annotations here, it'll just run the test twice? I don't know what use case you could possibly have for that. But I guess it's the thing. Okay, I'm glad we got that out of the way because that was going to drive me up the wall. So move to hallway slot. So this is self.move to hallway slot. Ta-da. Yeah. Yeah. So move to hallway slot. We need to move from slot into hallway. That's going to be an exciting function to write. Did I call it that? Move from slot into hallway. Move to end slot. That's what this is already. Move to hallway slot. And this is move to goal slot, we'll call it. You know, after all this effort, I hope this works for part 2. Self.move to goal slot. And this is going to have the same function signature because we're going to return maps. We're going to take a self. We're going to return maps. This is going to be a to-do. Okay. So we have looked at all of the hallway slots and we have tried to move them into goal slots, right? And if we can do that for any of the characters, did we do it for any of the characters or did we just do it for the first one? Movable characters, we did it for any of them. Okay, so now we need to do for any of the possible move outs, single move outs. So there's 4 options here. We can do 1 of 4, right? We can take any of the 4 that are in the slots that are not in that are the top, right? So we have 2 in the slots. If there's 1 on the end and the 1 on the end is not supposed to be there, or if the 1 on the end is supposed to be there, but the 1 under it is not, then we move it out. When we move it out, we can move into any one of the available hallway slots. We need to move that one into all of them and return all of those maps. And we need to do that for every possible move. So that's going to be a load of the same logic. See, it's noon right now. I think I'm going to spend half an hour writing this, and if we're not done in half an hour, I'm going to do the rest off stream. But this is the plan. We basically just did the first, right? We did the first. It works. We move from hallway to slot. Now we need to move from slot to hallway. And I think, yeah, because we are not going to move anything out if it already matches, so we'll be good. So what did I just say? We need to move for each possible move out. So self dot slots dot iter dot numerate. We aren't calculating the cost yet either. That's another thing that we need to do. And I want to get the end state first. But that's why I'm keeping the enumerates around, because we need to detect how far it's gone. Actually, we should probably do that first. How did I think about it? We have the indexes, right? So I guess we'll just debug it out for the moment. This is going to be car index no, it's going to be slot index dot max car index minus slot index dot min car index cost. Hallway cost is this. And then if we have a vec, so we do space cost equals slot dot length minus, or 2 minus slot dot length. Right, because you're into the space, and if it's a length of 1, it's 1. If it's a length of 0, it's 2. So slot here, is it going to complain about that? Let's do this. And we need to do this before the push. Right? Because we want to get the slot that we're pushing into, determine how many spaces it has, and then calculate that. So space cost, so it's going to be hallway cost plus space cost. And to test this, I'm just going to panic the other test and make sure that the debug comes out. We should be returning this though. You know, I'm just going to return it instead of doing this debug thing. So this is new maps.push map cost. And this up here for our new maps is going to be a vec of maps and their costs. And the return type is also going to be maps and their costs. And this is going to be moved to hallway slot with current cost, which is a U size. Move to hallway slot. Did we put cost back in map? No, we didn't. Current cost. U size. And then it is current cost plus hallway cost plus space cost. So for a character in slot A in this test down here that is now failing, we are going to have a map. And I think the first thing I'm going to do is make it a cost of 0 so it fails. No implementation for map equals map U size. Does move to hallway slot still? Should be a vec of tuples, right? Move to hallway slot, vec map U size. current cost. We aren't passing in 0 here. Did I change the wrong thing? Or is the other test also failing now? Right, so this is a vec of map use size, because this is 0, because we haven't moved. Right. Actually, this is still going to be 0. So this fails because we get a cost of 2, which I think is right. I think it's over 1, down 1. So in our test, these are massive objects. In our test, this is a cost of 2 because it's over 1, down 1. And the other one has nothing. Great. Wonderful. Now we're tracking cost, which we need to do. Okay, back to our other function. I'm starting to get hungry. That's gonna be the ender of this stream. I'm starting to get hungry. Let's see. So for each slot, for each enumerated slot, I suppose, because we're going to need to cost this, we are going to get our slot and slots. Yeah, I can feel it. I can feel my vision being like, oh God, you're starting to get hungry. Slot, use size homes. This is going to be filter. We wrote this filter above, so I'm just going to go grab it. Why is that yellow? Space cost. Value assigned to space cost is never read. Yes. Not here, but there it is. I'm going to ignore that for a moment. Where's our filter? Filter map. We did do a filter map on them, didn't we? That was the right move. Okay, so we've got 4 slot in filter map. This is going to be slot, index, and slot. We're going to go over each slot if it has a size. Then we want that, right? Let car equals slot.pop. I don't really want pop here. I mean, like I do, but I'm just going to deal with it later, I think, when we construct the new map like we did before. I don't think I want to modify this one. Unless we do, because yeah, we're going to need to construct a bunch of new maps, and I think we're just going to do that later. Unless what we do here is actually let new base map equals doesn't really make sense though. I can always do this later. I do want to use pop, but I want to like just copy the last one off for now. Let's see, Rust, Vec. I need a better search. I need to go directly to the Rust docs. So there's pop, right? Is there like peak or copy or leak? No. Is empty, insert. Is empty as a function? Huh. That's cool. I don't know why I didn't know that. Probably because I've just been checking the length. Let's do that quickly. Slot that is empty. Not. Is not empty. There we go. Done. Wonderful. We love improvements to our code. Big wins. Capacity dedupe as slice append allocator. We really don't have like a non-mutative pop. I mean, I could iter last, I guess, right? Which should give me the reference. But then we have to dot next on everything. It's not going to be super expensive because these are small iterators. But it's not really what I wanted to do, right? So space, this should only have occupied spaces. So if let occupied car, we're going to call this slot car. Clock car? Slot car. Else is going to panic. All slots should have occupied spaces. And then what? I can feel it. I can feel the food starting to affect me. All right, we're going to get this. We've got 15 minutes. Let's do if let occupied slot car slot.iter.last unwrap. So if the slot is empty, then there's nothing we can do because this is like a move out of slot function. If the slot is not occupied, then we have a panic because even though I didn't encode that property into our data structures, that is a thing that we're trying to enforce. We iterate over the slot, we get the last one because that'll be the one that's stacked on top. So 0 is the bottom, 1 is the top. Then we need to check for possible hallway spots. So we check for the index that we have, which is slot index. And we check for any index that exists that is a movable space. So let's find movable spaces first. And this is going to be self dot hallway dot iter dot enumerate, because the enumerate is important for the indexes. We're going to find, I think, all of the spaces, because we need to find the ones only that we can move to. We do have the index that we are at. So let's filter this first. Did we filter this up here? We did filter this up here. Get move slot. Let's filter cars. Movable cars. I think movable cars is what we were going to do. This is filter map for occupied. We want to filter map for empty, right? Because the way we set this up is for the hallway to have either... Ooh, you know what we didn't specify? Dang, we didn't specify which of the spaces could be walls, right? Or not walls, but like empty... Occupiable? Occupable? I guess empty is it, right? We already have this technically, right? We have all the slot indexes. Self.slots.iter.enumerate. And what we want here is to filter down to the IH. Let's get rid of the types for a second. IH. We're going to filter map here, so it's going to be sum. So filter map, match H, fill match arms. This is either going to be a wall or a home. If it's a wall, it's none. If it's a home, it's the index. Right? Sum index. We don't need that. We need this. We need this. We need that. Why is that complaining? Because I didn't close the tuple and I'm not drinking enough water. Okay. So we enumerate, we filter map. We're filter mapping for the wall and the home to get the index. So this is all the slot indexes. Effect of use sizes. So now we can do what contains on slot indices. So when we enumerate here and we filter for the hallway spaces, we want to not include any of the slot indices. This is hall index and space. We filter for not being a hall index. Slot is empty if light occupied. Slot iter last. For each of the slots, we collect into a vec. Right, so we've got the slots that we're going to have to move out of. We have the possible places that we can go here. Right, so iter, enumerate, filter, hall space, space. If it's not a space that's in front of a slot, then it's valid. And we keep those because we're going to have to later check to see if any of the ones between the one that we want to get to and the one that we're in are occupied. So hallway, iter, enumerate, filter. As long as it doesn't contain a slot index, then we keep it. Why is filter complaining? Is it because I'm not collecting? No, it's not because I'm not collecting, but why is filter complaining? Because I messed this up again? Yes. So we filter, index, space. We want to keep these, so we're going to filter map them. We're going to get if this, then some hall index space, otherwise none. Let's reverse this because I think that's a little bit more readable. If the slot index contains the hall index, which needs to be a reference, then we don't want it. Otherwise, we keep it. We collect into a vec of usize space. Right? Did I mess something up there? I think I messed something up there. Value of type, vec, usize space, cannot be built from item, usize space. Is that because I didn't put it into a tuple? Yes. I wish that that was a little bit more obvious. But Rust did tell me I did something wrong and also told me exactly what it was. So we've got the possible hallway spaces. Some of these can be filled, so we need to keep that in mind. So if slot is not empty, and we get the slot car out of it. This slot car, I'm gonna sneeze in a second. You know that feeling where you're like, I need to do this, and then it never comes? Slot car. So we have the one that we need to move. We have the possible spaces it can move into. It can't move into a blocked space, and it cannot move into any space that is too far in either direction of a blocked index, right? So I guess we could just keep iterating over this then. Right? Well, we need to have the copy of it, I think. Do we need to have the copy of it? We need to self-reference. So yes, we need to have the copy. Possible hallway spaces .iter. We'll check for each space. We'll match on space. Why is that complaining? It's going to complain because we don't have the match arms filled out, right? But why is Rust Analyzer not helping us? Okay, usize space. Fill match arms, empty. If it's empty, it's a possible. If it's occupied, it's definitely not possible. If it's empty, possible if not blocked by occupied space. So for I space, impossible, then match space. So how do we tell if this space is blocked by an occupied space or not? We take the index of the slot, right? So slot index, and we compare it to the space, not the current space index. Is it the current space index? I think we can do it this way. I think if we do hallway spaces dot iter dot filter, let's do find. Let's do find on the spaces. And we have space index, and we have, is it not space index? It's something else, right? Slot index. Slot index. And what's the other thing we have? You can see me starting to forget my working memory. Slot index, slot car, possible spaces. So we only have the space that we're looking at. And this is space index, possible space index. So we have these two things, right? And we need the range. So we have slot index dot max possible space index dot dot equals this expression again, but it's going to be dot min. Let blocker equals this. This is complaining because we have to put more parens around it. Found reference to usize. That will be the issue, I think. Right. Wait, is it telling me the wrong thing? Possible space is the reference. I put this on the wrong one. Expected bool found unit. And this is going to be dot contains I. So if there is an I between the index of the space that we're trying to move into and the space that we're in, then we're blocked. I guess we do if let none equals blocker, then add this to maps, right? Then it's a valid space move. So we need to score it and move it. And we're a little bit over the half hour, but I think that I'm just going to continue because I'm making good progress. If I get stalled, then I won't. I'll give it another 15. So we do some kind of new maps here, right? This is going to have to be outside of the for loops. So it'll go here, let new maps equals this. Slot car, why are we not using slot car? We're going to use slot car, right? So if we don't have a blocker, then this is the point at which we remove it from the 0 or the slot. And we also I keep getting like small notifications, and I'm getting a delivery today that is sometime before 8 p.m. So it's like eventually sometime, if I pay attention all the time to my phone. If let none blocker, then we need to do the same thing we did up here. Is it going to be basically the same logic is my question, right? We do a new map. I'm going to copy this in because this is what we're doing. And we need to do it slightly differently, right? We get a new map, which is the self.clone. The old space is not going to be in the hallway. It's going to be the slots dot get mute, right? New map dot slots dot get mute gets us a specific slot. That slot, do we have the index for that number? We don't, because we just popped off the last one, right? So maybe we just pop here. We're going to get it as mute. It'll be the slot index. This will be the slot. I don't love that we have homes here. Wow, that is a bad soundbite. Slot dot what? I think we're going to do the if let home thing. I already messed up. This goes here because we're going to get the slot index. We're going to pop one off of the slot index. And then all of this is going to get commented out for a second. Why is slot.pop not happening? Because it's not in homes, so we need to do if let home, which is the only thing it can be. So we're going to panic if it's not. if let home slot equals home, slot dot pop, else panic. I need to write a real sentence there. Home slot should always be a vec here. So we pop it off the slot. We are going to calculate the distance here at some point, but for now we just pop it. And then we need to move this character in somewhere. This needs to work, so we'll unwrap it. New car here. We need to get the new space, so new space will be this instead of old space. New map dot hallway dot get mute. It's not car index anymore, is it? Did I call it hallway index? We're in a loop. Possible space index, I think, is the one that we're going into. That's home. This is new car, new car. New map, home, new car equals, this is wrong. No, that's right. New car. New space equals new map, hallway, get mute, possible space index. New space equals new car. Then we have to calculate the cost, right? So the cost of moving to this space is two things. Did we do it up here? Slot.pop. We can calculate the cost up here. So let's do it here instead of doing it down there. Why did I call that space cost? I guess as a comparison to hallway cost, but... So this is going to come up into the spot that it is supposed to be, which is here? Yes, here. So space cost is 2 minus slot dot length, because it won't be 0, right? And if it's at 1, then it's a cost of 1, so it moves up 1. No. Yes. Is that accurate? I think we count all of the hallways in the other one. So what we do here is 2 minus slot, because we're still calculating the same value as before. So if it's 2, then the cost is 0 because everything's in the hallway. If it's 1, then the cost is 1 because it has to move up 1 before it can move into the hallway. And then the hallway cost is the slot index, car index, which this is possible space index now. Right? The two indices dereferenced as values. And then we have the slot index to the car index, the max, and the min, which gives us the full distance. And we need to pass current cost in, which we aren't doing. Wow, did I write that entire function? So current cost up here is going to be 0 because we're trying to just get both of these maps in, right? And then all the way down here where we do our new maps, somewhere. We do new maps are somewhere. New maps dot push new map current cost hallway space cost. So we are getting that back. And this is new maps, right? This is map cost. So there we go. We should write a test. We've got 2 minutes. I'll write the test because it would feel really awful if I didn't write the test and then it failed. Let's make sure that this works here. Okay, so we have a move into slot 2. This is move into hallway 2 or something like that, right? So all of these are empty. Actually, this is going to be move into hallway because it'll move into each of the slots. We have occupied A. This is going to be occupied B because we need it to move. So it therefore needs to be not the correct thing. So in this case, it'll take all B's and it will move B's into the hallway. We will end up with effectively a ton of B moves, right? Move into hallway. I didn't write the right function here. This is move to hallway slot. Why did I name that move to hallway slot? That's such a horrible name. Did I name these the wrong things? This is move to goal slot, and the other one is actually move to hallway slot. I reversed this. Why did I do that? Okay, both of those move to goal. This is move to hallway. The tests now need to be updated. Why did I name those that? That's one of those things. That's why you like pull request to review your own code. Goal slot. Goal slot. And this one is hallway. So we should still get 2 passing and 1 with a massive amount of output. Correct. That is exactly what we get. But holy crap, do I not want to write this? So I'm going to do something that you probably shouldn't do. And I'm going to copy the test output here. And then I'm just going to drop it in here. Bonk. I copied the entire thing, didn't I? And I didn't need to. This is going to be a whole thing, isn't it? Okay, let's do... I've committed to my fate. do this for a second. One, two, three, four, five, six, seven, eight, nine. I think that we didn't. Oh, is it for every single character? Oh, dang. Oh, dang. I'm glad I didn't copy this, but at the same time, this is going to be a lot. I'm glad I did it this way and didn't type it out. Okay. Okay. Second to last one. And then this is just going to be Vec. And I'll just manually do this last one. This is going to be an absolute monster when I format this. Okay, last one. Is it just going to fail? Is it not even going to? Expected struct vec found array of 11 elements. Okay, which one of you little... Oh, tell me that's on all of them? Is it only for the last one? It's only for that one for some reason. Did I miss the first one? That's possible. God, could you have imagined that if I didn't understand how to, like, do that in VS Code? That would have been awful. At least now we have, like, confirmation that, worst case scenario, we can count these out and look at them. Okay, so we have move in, we have move out. We have the costs. Enumerate moves. Start with 0. Get a bunch of maps. I think what we do here is do the same thing for all of them again. Like... This isn't going to be a vec of maps anymore. This is going to be a vec of maps and costs. And this is going to be new maps.iter dot chain additional maps.iter dot map. I guess map is the wrong thing, right? So what structure do we want to pull this into? Just a giant vec, I guess. So we're going to have to dot collect here on a vec of map usize, right? So we're just going to chain these iterators. We're going to collect like that. This chain needs to get turned into something. Was it me, Jesus? I don't get the reference, Derek, but I'm sure that it was funny. Because I know your sense of humor, and I know probably where it came from. Vec, map, usize cannot be built from iterator over maps and usizes. First of all, we don't really need these. Well, we do, because we're going to return them, and we're creating them. But we have to... What do we have to do here? Map... Flat map? Is it going to be flat map? Let's just start with map. Let's start with map. And this is going to be m usize. And what we're going to call here is m dot enumerate moves. We're going to fix our syntax errors because that's fun. We're not going to call this usize because that's not valid. And I think we're passing this in because it comes in as a reference. And then what we get back is actually a giant vec. So we flat map it. And then we do that. And then hopefully this works. Where is even process part one? Okay, we have our start map. We have our goal map. We have our enumerate moves, and we have new maps. I'm not going to debug all the maps out because that sounds awful. No, not part two, not part two. Part one. Expected unit found usize, totally fine, don't care. Not yet implemented. Where do we have it to do? In puzzle input? Yeah, that is a to-do. You're absolutely right. But you know what we're going to do? We're going to ignore that. Main has overflowed its stack. That's not fun. We just need the cost. But if we're going to call this recursively, we do need this. Today I learned you can stack overflow in Rust. You can definitely stack overflow. How do we get around the Stack Overflow is the question. Because really what Stack Overflow means is infinite recursion, right? So the additional maps, interestingly, always have a ton of numbers. We aren't, you know what we aren't doing, actually? New maps.push. We aren't checking to see if we should even move them out. So there's more work to do here. But it is little fiddly work, and I do need to eat. So I think I'm going to end stream there. The things that we need to add, I think all of this works, right? I'm fairly confident all of this works. We did it individually. It moves out and it moves in. We have a couple of the rules built in. The thing that we really need here right now is to check to see if the space that we are trying to move out of should be moved out of. I think that's it. These are definitely bouncing back between two very specific numbers. And I think it reaches them immediately. So we start with 28, we go to 24, and then we bounce back and forth. So my guess is these are getting like popped out and popped back into the same spots. So I'm going to go through and I'm going to make sure that we encode the move out rules correctly. But it does move out. We did confirm that, right? If we look down at the plethora, the absolute just magnitude of test cases that we have here. We have B, A, C, D. So B in the first slot. And it got moved out of this one, right? B in the second slot, and it got moved out of this one. B in the fourth slot, and it got moved out of this one, which is this is the second slot, second index. So that's the right place. That gives us all of those. So we just aren't stopping. We're just bouncing around in this recursion. And that's what the Stack Overflow is coming from. So this recursion needs to have a stop case. And it doesn't. But you can see that we're popping a character out and then putting a character back in, right? So I think on this first one, we get this list of maps, and then we're recursing in, and it's not saying that we can move one in, so we move another one out. And I think the one we're moving out right here is actually the A character, which shouldn't be moved out. So if I can find that spot quickly, I'll write it on stream. If not, then I am going to leave it, and I'll talk about it tomorrow. New maps.length 1. So where should we put this check? The question is, we have slot car, right? That's the wrong function. I'm already messing up. Slot index slot. Let's grab the other thing that we had up here, right? We had this zip, this car set zip. So for slot index slot in self, filter for just the ones that exist. If the slot is not empty, and and occupied should move out. Then we do this. Where slot comes in here in this collect. So I really just collected right into that, didn't I? Let's do this. Let's do let equals this. Make it very clear that I am not choosing a name here. Dot zip car set. Valid car for slot, right? For this, if the slot is not empty and slot.all why does that not give me slot.iter.all space I didn't make these occupied, did I? I collect this into spaces. That's fine. Whatever. All space. Occupied. Valid car for slot. And this is going to give us a type error. And this is going to give us a type error for possible space index, which is awkward. But that's not what we're looking at right now. We are looking at 163, expected car, found reference to car. It's not what it wants, though. Can spaces not be compared? Is that going to be my problem? Did I not do econ spaces? This is a lot of code. You know, I did do econ spaces. Let's go back up to 163. And this needs to be a reference for the equality to happen. And these references changed a little bit. I know now it's getting awkward for me to like show the code because it's so far indented. What is this? 196. I needs to be, really needs to be a reference? Okay, whatever. Slot index needs to be that. These are okay now, I think, because slot index's type changed. And then we've got additional work to do, it looks like. So I don't know what other rule we didn't encode. Oh, actually, you know what? These are all moving from hallway into, right? So maybe we need to add another check there. That might be B trying to move in. So this is just what I'm going to do. I'm going to keep encoding more of the rules. I'm going to keep going through and making sure that the rules are being properly applied. This is a long one today. It's not, and then I think that this will also work once I get it for part 2. Because I assume that the only change that I'm going to have to make for part 2 is to parse in the board. But we'll see. Wow, that runs like instantly. This just rips, absolutely rips through these. Yeah, so we end up with new maps 28, 18, 15. So it moves out as many as possible for a while until we don't have any more to move out. And then it starts trying to move in. And when it starts trying to move in, it looks like I'm doing something wrong there. So that's where I'm at. I'm going to finish this up off stream. I'm going to get some food because I need food. And thanks for hanging out. We will be back, I think, tomorrow for the final day. I think tomorrow's the final day, right? Let's check the... Let's check it first before I claim that tomorrow is the final day. Calendar. Tomorrow is not the final day. Tomorrow is the second to final day. But we'll be back tomorrow, 10 a.m. Hopefully the next 2 days are a little bit easier. These have been getting a little bit tedious to code out. But I'll catch you all tomorrow. Thanks for hanging out.